And today's feature presentation is about Arrowhead Copilot, how to design, what is the latest about it, how to access our Copilot and things. So presenter is Csaba Hegedus. Csaba, the floor is yours.
Good day, everyone. This presentation will be almost the same as was given in the Deep Tech workshop in Budapest in November. But the purpose is now to show you how you can use it and to advertise it so you request access to it. So there is a staging environment where the Copilot is available. And if you write me an email to my address here, I can grant you access, and you will be able to check it yourself. And this presentation is only there to refresh what it's supposed to do and to walk through the actual system. So very short presentation. First, there are copilots, which are essentially chatbots using large language models. And there are a couple of features that LLMs have nowadays that are quite interesting and quite useful for certain use cases. There are two features that LLMs have that are interesting to us, or three actually. The first one is that we can contextualize them and provide them a knowledge base that they would be able to search. That is called retrieval augmented generation. The second one is we have now reasoning LLMs that are able to use tools and create plans when they are presented with a multi-step problem. So they are able to plan solution steps, and then they are also able to execute them using tools. This concept ties into the whole agent concept, where we have an agent who is acting on your behalf as the user. And the third one is that LLMs are also good at generating artifacts as generative AI. So they are able to generate source code in various domains. Now this latter one is not in scope for the demo system, but the first two are. So what you're going to see is a RAG chatbot, a retrieval augmented generation chatbot that has knowledge base in Arrowhead, documentation mostly, and papers mostly. And there is a second feature to the chatbot that we call a planner engine, which is essentially an engine, a reasoning engine that has access to Arrowhead core systems real-time via APIs. And the planner engine is able to solve more complicated queries via natural language. So having these three things in mind, we have a concept you may remember is that we defined three copilots. That's on the diagram here, related to the engineering lifecycle of system of systems. And you will see the second two, the second and the third one here. We call them the Arrowhead Runtime Copilot and the Arrowhead Chatbot. Now this is presented as one system, so you will see one system, but capable of these two feature sets. I'm not going to talk about retrieval augmented generation because we sort of dissected it in November, and hopefully you remember, but just the two-sentence version of it is that our chatbot has access to Arrowhead documentation that I will show in a minute. and it is able to answer questions based on that knowledge base. And the second thing that I wanted to show is the planner engine that I'm going to show, which engine has an internal reasoning engine, which is able to understand Arrowhead APIs and able to use those APIs in real time to facilitate more complicated user queries. For example, we will show a scenario where I ask if the gatekeeper has any active services. And based on this user intent, the engine will realize that what API calls need to be made. Those API calls will be made to the service registry. So the system will realize that service registry contains active services and not, for example, authorization. And service registry will have also like 42 different API calls. API calls will be selected, assembled, and then executed. So this is the demo. And you will also have the ability or the access now. So if you again write me a mail, you will have access to the system. Oh, sorry. You will have access to the system and you can play with it yourself. Now, what you see as a chatbot when you land in the application, this is stage.arrowheadcopilot.online. And it has, chats, annotated chats on the left side. Let me just start a new chat. You see that I will be able to just type in queries or add sort of multimodal messages. So I can, for example, add this image and I will be able to ask from the image, which is a local cloud image. Let me just show it to you as well. So it has a simple arrowhead diagram with a car provider and car consumer. And I'll just attach this message and ask, is the car provider system, or is the provider system from the image currently registered? Yeah, hopefully this will work. Otherwise, it would be a very bad demo effect. Okay, now the system realized that this is a real-time request, so it will invoke the planner engine, as you see. I have two choices. I may let the system run in silent mode, which is when I don't care what it does, just get me the information, or I can go into the editor mode. The editor mode launches a new view. I don't know why it's so slow. So it starts this wizard kind of thing, and it starts a workflow there. Now, one thing is interesting is that the system has the Arrowhead core systems added as plugins. I'll just jump to the plugins in the meantime. Each Arrowhead core system, as I said, has is a plugin, which is essentially details on how it can access. So there is a URL for the core system, and there is the open API specification of that core system registered. There is also a manifest that each plugin has. For example, a description and a name. And authentication is is not yet implemented, but our system will be able to, well, it's sort of implemented because we use the MTLS of Arrowhead, but in the future, the system will also support OAuth 2 and API keys. So different authentication methods will be added per system. But anyhow, this all the core systems are added, so it should be good. Now, if I go back to the chatbot and to the workflow, I can see and trigger which core system to be used. Now, you can leave in all three all times because, again, the system is able to select which core system to use, but just to make it faster, I'm going to skip orchestrator and authorization because OpenAPI specs would be added to the planning engine, and that's a lot of tokens and a lot of time. But let's see, we can leave in the orchestrator or let's say the authorization, so it should be fine, just extra time will be taken due to token count. So now the engine is considering the OpenAPI specs from the plugins and will come up with a plan, hopefully. Yes, it did come up with a plan on how to solve. You see, it recognizes that it needs to call the service registry endpoint, and then it needs to filter the list it receives, and then return if there is a car provider or not. And this plan is humanly editable, which means that I can just move around parts of the plan, or I can edit the steps of the plan. But for me, this seems acceptable. So let's continue. Now it takes the first task from the list, from the plan, and it will start executing it if I let it. So again, you saw I had access to the task itself, so I'm still able to change that if I want to. Now it recognized that this task requires a call to APIs. So there is another agent, because this is a multi-agent engine, that assembles the request to be made. And this is a Postman-like plugin here, or Postman-like accordion here. So as a human, I can overwrite any parameter that I see. Now, if this weren't a GET request, you would also have a body filled up, and if the GET request had filters, for example, parameters would be added, like query parameters, by the engine. But I can also do it if I know better. But let's say I don't know better, so I let it run and I get back the response. I can see the raw response from the system, I can see headers, and I can see status. And this is more interesting for like post kind of, so create or update kind of requests. But for here, it's like querying data for now. And based on the API call made, there is an assessment of the task list, or sorry, the task result, and we continue with the plan. However, if I do not like something, or I have some comment to the engine to consider, I can add a user review. But, you know, I can just say, please continue. So this is optional. Or I could, if it's going in a wrong direction, I can give it a boost into the right direction. Now it takes the next task, which is filtering the list. So that's fine. It doesn't require API calls, but it requires a different agent, an evaluator agent to run. And the list does not include the car provider. So there is no system like that in the deployment. Again, user review is possible. And now hopefully the engine will conclude the task. So yeah, there is a final answer provided by the system. And I can go back to the chat, and the main chatbot, which is the sort of the supervisor, is also registering the fact created. Now we are here, so I can provide feedback. And if you start using the system, I highly request you to use the feedback button for each message, if possible, or for case mode, for cases where you didn't like the response. And the reason is that we collect these feedbacks and we are able to see the chats happening. And for each message generated where we receive a, for example, negative feedback, we will be able to see what went wrong, and we could make the system better in the future. So that's part one, planner engine and real time. Are there any questions to this one? All right, then let me continue. The chatbot itself also has guardrails. So it checks each user input against language requirements. So you can only talk to it in English. If it checks if there is any profanity or anything that the content filters should well filter. And it also checks for the topic. Now, this chatbot is only allowed to talk about Arrowhead related and system of system related and IoT related things. So if we ask how much is the fish, how much is the price of fish, I really hope that would be flagged by the system. You see it was flagged, so there is a not on topic. And the system also, refuses to talk about it. Now I could put some profanity in the chat, but since this is being recorded, I'm not going to do that. But then in that case, the message itself is also redacted. So you will not see profanity in the chat history either. Now moving on to the other aspect is the rack pipeline and the knowledge base part. This system uses a completely self-developed multimodal rack pipeline that is primarily optimized for Arrowhead papers. What kind of papers? For example, 1 second. For example, this kind of paper. So 2-column multimodal IEEE kind of papers. And from these papers, there are currently 4 registered in the system, but you could add further ones when you get access. So feel free to play with our document pipeline as well. As you will see that those are added to the, okay, apparently there is still some authentication bug we need to get rid of, but if I go into this part, you will see an overview on the document. You can preview it, which is showing the PDF, and there is a table of content that is extracted by an agent, usually. And you can also edit each partition created. So For example, the system recognized a figure from the diagram, let's say this one. It is extracted, the figure is extracted as well. And there is a description provided by an LLM about the figure. So figures and tables are extracted as well, and they are contextually augmented, so to say. So there is a description created from the images and tables. And each partition created is based on the table of content. Let's say chapter 2, this is chapter 2 in the document, is extracted from as such. So this is an intelligent partitioning system used here based on table of contents. And moreover, you can delete partitions or edit partitions if you don't like. So for example, I don't need references, for example. This is a partition from the references, and I can delete it because it's not really good if these are essentially meaningless in a rack system if a paper has external references. So I can delete them. That's fine. Moreover, not just documents can be edited, but I can create like sandbox documents or virtual documents that are like notebooks. So if I want the chatbot to talk about my personal feelings, or was it diary, I can create a virtual document here, and I can add content there, and the knowledge base will include these as well. Now, obviously, this should be about Arrowhead stuff, but you know, it's just a notebook kind of feature. And if I go back to the chatbot and actually see the rack pipeline in function, I can ask like, what is a device in Arrowhead, or any other kind of question. And if I do that, it will recognize that this is more like a knowledge base kind of question and not real-time question. So it will trigger the whole rack pipeline. And it also has a silent mode, which is the don't care capability. And it still also has the editor mode, which is a very similar user experience to the planner engine. But the steps are different here. So the steps are related to the retrieval of documents and then generating an answer based on the documents. And for example, based on this question from the current knowledge base, it found like 4 relevant parts. One of them is a diagram. Now there are only like 4 papers in the current knowledge base, but the more the merrier. So I can see which parts are found from the database, from the vector search or the hybrid search. And then based on this one, I can ask the system or let the system generate a response, which is going to also include references. So if you see that the engine is retrieving an answer, it is also allowing you to see what made the reference here. And if you click on the reference, you will see the raw text as well, and you can open the document in like a new page and see that this sentence is grounded in this document. Yeah. And there is also a final answer, and we can go back to the chat. Now, one last thing before I overrun is that everything is monitored here. So there is an LLM ops framework behind it, the system. So we are tracing the discussions, right? So I'm able to see what's happening in the system. And if you, for example, provide the user the feedback, I can also check what went wrong. So yeah, that's about it. And we use GPT-4o and 4o mini in the background, but this is a completely self-developed solution otherwise. And it is also LM independent, so GPT-4o can be very easily replaced with Gemini or, I don't know, an on-prem hosted instance. And the reason for that is that this system, we are open to give it to anyone who's interested, and if they want to run it on-prem, like air-gapped in an air-gapped environment, that's also possible. And it doesn't even need to be Arrowhead specific, because the rack pipeline and the planner engine are sort of only contextualized with Arrowhead, and they can be contextualized with anything else, really. And the same engine runs the VP7. Oh, doesn't run currently, but there is the same engine running a different project for VP7, which is able to talk about the European AI Act. So that's about it. Any questions? Yeah, Guntis, you may have one.
Yes, well, this might not, if this isn't the right form to